Hello everyone, myself Badri Vishal. I am from Group 6. Today I am discussing about our project that is handwritten word recognition for Indian languages. So brief about our project is that we have handwritten word level images for three different languages: Devanagari, Hindi and Devanagari, Tamil and Telugu, and we want to recognize the corresponding word in it. Suppose this is a Telugu sample. I will give a Hindi sample. This is Denmark. This is Denmark written in Hindi language. We want to recognize the corresponding word in it. So for this, we use basically an open source library called doctr. CRNN model which supports CRNN model. So just briefing about this open source library. This open source library is present for OCRing text. OCR is text detection and then text recognition. This library is being used for OCRing printed documents, but in our project we try to use this open source library where we can train models from scratch and then recognize for Indian language words, and that too handwritten level words. And for this we get the data set of Indian language words from this competition called IHTR. This ISTR is part of IGDA 2023's conference, and we get the data set from here where basically there would be word level images, and then we have to predict the corresponding word. For this, we use the model CRNN model from this open source library and then train corresponding words. But before training, we need to do a lot of pre-processing. I will explain some of the pre-processing that we have done. One is getting the data set in the required format so that we can train the model, and the other one is like converting the images into grayscale and binary formats, because since it is handwritten word level images, it is of different colors: blue pen, black pen, and it is of different sizes. We wanted to model to train better, so we converted it to binary. And then we also correct the skew for the images. That is basically whenever words are present differently oriented, we try to correct it and make it into horizontal. So these are some of the pre-processing. And the other one important aspect is we have to get the vocabulary dictionary for that particular language. Suppose this is a Devanagari language, and for the entire data set we run through the Unicode characters that are present for the training data set, and we get the corresponding unique characters for that particular language. This would help the model to train on that particular vocabulary set, and once the training is done, it will be predicting based on the corresponding visual features that the model CRN model has recognized, and it predicts the corresponding character. So this is one of the important thing that we have done, that is getting the vocabulary for Indian languages, and providing it into the input for training that we provide here. And once we train the model, just we train the model for 100 epochs and uses different batches. We had to use GPU for this for training the model, because it the model was very taking lot of time, so we use GPU services. And then once we have trained for 100 epochs, and we have done this for 100 for three language. I want to just give a demo of our trained model. So we running the test images. The code is well documented. We can get the evaluation results and also testing the predictions. For testing, as you can see, I've just run the code, and the results are generated. In the outputs, we basically print the corresponding predicted word in the image itself, just for visualization purposes. And as you can see, we have got the correct prediction for this image, and this is the predicted text. And you can also see in labels.json, this is the image file name, and this is the corresponding word. And just for showing in for Hindi, these are the outputs for Hindi. As you can see, Denmark, it predicted correctly for this. And if you can see Rak also, so these are the predictions that we get. And for this we have trained three models. We have also submitted the models that got trained. And the corresponding evaluation results are also shown. We got a CRR of 86%, 94%, and 90% respectively. CRR is basically the character recognition rate, and WRR is basically word recognition rate. If even one word is missed out, we get a word recognition rate of 0, and we get 100% if the entire word is matching. So word recognition is very low. And also the challenges that we faced are that the models were basically made for printed documents, but this is challenging, not only being Indian language but also it is a handwritten based language. So there were lot of uh, different kinds of handwritings being present, and we have only trained for 100 epochs. We did not get better results, but we got competitive results for character CRR, and most of our predictions were matching. So that is our project. Thank you.